Hello and welcome to this screencast on unit testing and automation technology for OT professionals. In the IT world, unit tests are very common, but in the world of automation technicians, they are still relatively new. In this screencast, I would like to give you a brief introduction by explaining what unit tests are and the benefits they offer. And I will introduce you to SIMATIC AX, which comes with an integrated unit testing framework. What is unit testing? Unit testing, also known as module testing, is a method where individual components of a software are tested in isolation. Here are some of the benefits that unit testing offers. First, unit testing improves the quality of your software. By testing each component separately, errors can be detected and corrected early. This minimizes the risk of errors and increases the stability of your application. Second, unit testing makes maintaining your software easier. When you make changes to a component, you can immediately check through the existing tests whether the functionality still works as expected. This makes the process of refactoring and further development more efficient and safer. Third, unit testing promotes team collaboration. By writing tests, the requirements and expectations for a component are more clearly defined. This allows developers to collaborate better and coordinate their work more effectively. Finally, unit testing also enables faster development. Automated tests ensure that your components function correctly without having to manually test each time. This saves you time and allows you to focus on developing new features. Overall, unit testing offers many benefits for software development. It improves quality, facilitates maintenance, promotes teamwork, and accelerates development. If you're not yet working with unit testing, I highly recommend considering this practice. Unit tests can detect and correct errors early in automation technology. The benefits of unit testing are evident. Let's now see how we can apply this practice in a practical scenario. So let's dive in. We've developed a function called normalize value, and now we want to verify its correctness and robustness. I'll walk you through this process. First, take a look at the left side of the screen where you can see the Test Explorer for AX unit. When I open it up, you'll notice that there are already some tests existing. I will go ahead and run these tests now. It will take a moment, but once the tests are executed, the results will be displayed immediately, allowing us to quickly see if something is wrong. But now back to our original problem. I want to test my function normalize value. I go back to my workspace and here I already have a test folder where I can place my tests. In this folder, I can create a new file named testNormalizeValue.st. Just fix the typo. With that, I have a new empty test file. Since tests are just written in regular ST code, I'll create a namespace. It's the same namespace where my function normalizeValues resides. This isn't mandatory, but I've chosen to do it this way. Now I can create a so-called text fixture, which already includes a test method starting with the pragma test. This simply indicates that this is test code and should be treated accordingly. First, I'll give the text fixture a meaningful name, such as testNormalizeValue. For the test, we need a few variables to hold the input values and the expected result for the function, and so on. Here we finally call our normalizeValue function and provide it with the necessary parameters. And finally, I want to verify that the function's result matches my expected result. Therefore, there are some built-in assertions like equal, which checks if my result is equal to the expected value. Now I clean up my code a little bit and don't forget to give a meaningful name for your test method. And you can also place some comments. And because one test is not enough, we define additional test cases. I'll just add them here and format my code nicely. When I now go back to the Test Explorer, I see that my newly created tests appear. I simply repeat my test run. It takes a while. And as we can see, these tests also run successfully. Means I did a good job. If you look closely, you'll notice that we've created 4 test methods here, even though they only differ in test parameters. This approach is, of course, much more labor intensive and harder to maintain. That's why SIMATIC AX provides the capability to create parameterized tests. Let me show you how it works. To do this, I'll create a new test method called test cases for normalized value. Now we want to pass the test parameters into the test method, delete the initial values, and define our first test case as follows. Since we had 4 test cases, I'll simply copy the first one. Initially, all tests are marked in red. This is because I now have 4 identical test cases. Now I'll retrieve the comments and parameters from the existing test and adjust them accordingly. Before running the test, I'll delete the redundant test methods. This makes my test code much clearer. In the Test Explorer, I see my 4 tests again. I click on play and wait for a moment. And voila, these tests have also successfully passed. So far, we have always seen the best case scenario. All tests passing successfully. But what happens when the tests fail? I will show you that now. I have intentionally introduced an error for this demonstration. Now you can see that one test is highlighted in red. This means that the expected results does not match the function's output. I can jump directly to the faulty part to analyze it further. To do this, I can set breakpoints and then start a debugger. The program execution will stop at the breakpoint. Here I have a debugger menu where I can choose various functions like step over or step into. This allows me to navigate through my program code. I can also display the values of the variables. Now I understand where the error lies. I correct the program code and run the tests again. We wait for a moment and voila, the tests are now running successfully. I hope that you've enjoyed the demonstration of SIMATIC AX unit testing framework. I like it very much because it saves me time and money during the development and ensures a higher level of the software quality. In this screencast, we've explored the fundamentals of unit testing and its significant advantages in the world of automation technology. We've also seen a practical demonstration using the SIMATIC AX unit testing framework, which not only simplifies the testing process, but also enhances the quality and robustness of our software. Thank you for joining us in this screencast. We hope you find it insightful and are inspired to incorporate unit testing into your automation project to achieve higher software quality and efficiency. Happy testing!